Okay, is my mic up? Can you hear me in the back? That's better. Excellent. Thank you all for coming along this afternoon. Just before I start, did anyone go to Piotr's talk that was just before this one? Okay, so that's kind of interesting. I had no idea that they were going to schedule like 2 moving to Java 11 talks back to back. And in fact, Stefan only asked me to give this talk a couple of weeks ago. So my view on this is going to be probably, I think, a little different to his. So, but it's good to see that so many people are interested. So who is actually currently running Java 11 in production? Who is running just Java 8? Any poor souls out there on a Java version below 8? 1 person, 2 people. I'm very sorry. You should. Kirk, I told you not to heckle. No, I'm not very sorry about 11 at all. 11 is lovely, as we shall hear. So this talk is kind of a work in progress. You know, when I put it in, if I'm going to be completely honest with you, as I think speakers should, I expect it to be done now. I expected to have completely finished my migration at New Relic to get everything moved over to 11. This has not been the case. It actually turns out that while the code aspects of 11 are relatively easy, the human parts, less so. Who would have known that the code was the easy bit and humans were the tricky part? Who could have possibly guessed that? So that's why I think my title is actually slightly different. It actually has the present tense, if you can see that. It says migrating to Java 11. So we're not fully done yet, which is kind of a spoiler for the end of my talk, but never mind. Okay, so I work for a publicly traded company, so I have to have a safe harbor slide. Has anyone ever actually read any of these? I certainly never used to. But now, whenever I make forward-looking statements, such as the ones I'm going to make in this talk, this slide has to appear. For those of you who haven't met me before, I'm Ben Evans. I am Principal Engineer and the Architect for JVM at New Relic. Before that, I was one of the co-founders of jClarity, which sold to Microsoft earlier this year. And before that, I spent a long time working in various financial companies, notably Deutsche Bank and Morgan Stanley. And if you want to hear war stories about the Google IPO and where all the bodies were buried in that project, then buy me a beer later. The other thing that I'm kind of known for is my work in the community. I'm a Java champion, Rockstar Speaker, and I served with Martijn Verburg on the Java Community Process Executive Committee for 6 years. Sounds really grand and important. Lot of really fairly mediocre committee rooms were involved. But, you know, somebody has to help, you know, make sure that the standards go through the proper process. It's like that old joke about, you know, legislation and sausages. If you're a fan of one, you should never really see how it's made. But today we're going to talk about Java 11 and we're going to talk about New Relic. Hands up if you have heard of New Relic. Most people. Hands up if you have used New Relic. Few people. Okay, so that's probably good that I've got that first section in to talk about what New Relic actually is and what we do. And then I'm going to talk about the migration and the challenges we ran into at enterprise scale. And then I'm going to finish up by really talking about our future state architecture, why we're doing it, what we hope to get out of moving to Java 11, and our roadmap from here on in. Okay, so let's get started. So New Relic, broadly, is a performance monitoring company. Okay, we are a public company. We've been public, I think, 8 years now. And we look after all of the metrics and all of the monitoring in your system so you don't have to. You know, sometimes people like to build their own bespoke monitoring systems, and that's fine. But above a certain scale, you spend so much time caring and feeding for such a beast that it kind of makes sense to get somebody else to do it for you. And that's really the business that we're in. We handle billions upon billions of events per day. And we have just launched a new platform called New Relic One, which is kind of about observability. And what does observability mean? It kind of means that we care about the same things that you do, that we try to see your systems in the same way that you do, and to actually understand what's going on at an entity level. Now, Java is really, really important to us at New Relic. It's the majority of our services. We also have quite a few Kotlin services. Hands up if you're using Kotlin. Only a few people. I'm always surprised by that. Kotlin is a sweet little language, and I really don't understand why it hasn't taken over more and gained bigger market share outside of the Android space. We don't have a strong bias. One of the things about New Relic as a company is we tend to be kind of not quite anarchic, but certainly teams and individuals have a very high degree of autonomy. So we don't tell people, you will write your services in Java or Go or anything else. We kind of try to have a much lighter touch than that. So a lot of our folks do like Kotlin a lot. One thing we are very, very interested in is Kafka. Hands up if you're using Apache Kafka in your systems yet. Again, fewer people than I would have expected. Kafka is, I think, is going to be one of the big things to come out of architectural trends for the coming few years. And if you haven't already been exposed to Kafka, I would think it's probably a good thing to actually do some reading about or try to pick up on, because it seems to be spreading, and with good reason. It's very, very solid technology. Okay, so that's all well and good. What does it actually look like? Well, our architecture kind of looks like this. Right? Your Java app is up here, and in it you have got this blue box, which is our New Relic agent, which is just a jar. I'll explain how it works in a sec. It sends us events into this data pipeline here, which get fed into Apache Kafka, which get fed into our microservices. There's actually a lot of enrichment and reading and writing in the Kafka pipeline that goes on, so lots of services will read stuff out of Kafka and then write it back into another set of Kafka topics further downstream. We also have this thing called NRDB, which is essentially our proprietary bespoke database. We're among friends, so I can tell you that secretly under the covers, it actually the actual storage of the data is actually in MySQL shards, but we actually have a proprietary thick middleware layer on top of that, which basically allows us to do some kind of smart routing and some clever sharding and stuff over the top. Basically, off-the-shelf MySQL doesn't really scale to our kind of data needs, so we needed to put something else in that would be more suitable. And then finally, it all gets sort of fed out into a dashboard. And to give you some just sort of general picture of how sort of the timescales involved in this, our agents, you can configure how long they pause between sending us data. But if they're sending us data every, let's say, 15 seconds, then we would expect to have that data visible in the database and displayable on the dashboard in under a minute. So we talk about the time to glass, which is the event being generated in the agent all the way through to coming up on a customer's screen or web browser, and we call that the time to glass. And our general feel is that should be a minute or less. It would be nice to be lower latency, but there's some processing that needs to happen along the way. And in particular, Kafka is not particularly a low latency technology. It's very good at lots of things, but it's not optimized for that latency dimension. Okay, so this is a sort of a pretty high-level view of what our architecture looks like. I'm just going to say a couple of things about Java agents, because they are, well, this is a Java conference. So let's talk a little bit about the tech that we actually all use. So Java agent, which is kind of a general term used in the industry. We also use it, as probably a bad overload of the word internally at New Relic to mean the code that plugs directly into your applications. But in the Java case, what we're really doing is we're using the Java Lang instrument API. Anyone ever played with Java Lang instrument? A few people. Yeah, it's not a particularly common part of the SDK, but it is quite fascinating and quite fun if you like that sort of thing. So basically, to do it, what we want to do is we want to, without any prior knowledge of your application or having to be compiled in, we want to simply modify your applications as they're loaded. So basically, what this turns into is essentially bytecode rewriting. And we pass in a special startup flag, which has the Java agent on it. The agent jar basically contains a manifest, which indicates metadata. It contains a thing called a pre-main class, which indicates a special class which needs to be run before the main method of the Java application is actually invoked. And this contains what we call a pre-registration hook, and basically allows us to using the Java Lang instrument API, to basically to register some special components. So, for example, the pre-main will look like this. You see it has some arguments, which will have come from the command line, and the instrumentation objective will be fed in automatically. The API basically provides us with a simple hook, and we can essentially do some rewriting and call back into a library like ASM or CGlib or ByteBuddy in order to modify the bytecodes of methods as we're seeing them. So what we tend to do is we tend to kind of put in like a special invisible to the developer call to a registration hook. So if you want to know how long a method takes to run, you automatically insert a probe at the top which says we entered this method, and you automatically insert a probe at the bottom which says we're leaving this method. And the difference between the two timings will tell you how long you're in the method for. Okay, so that can be done. It's not completely trivial because you have to be careful about how you modify the code. But there is a standard body of literature about how you do these things. We tend to use ASM, which is the library which is also used by the JDK. And in fact, there's a modified version of ASM hidden inside every Java 8 and up, which is used for things like Lambda expressions. Okay, so that's kind of a whirlwind tour of what our architecture looks like and some of the concerns that we have as a company. So let's move on and let's talk about migration at scale. How do we actually take a company the size of New Relic, which has around about 1,000 engineers? I wouldn't like to speculate how many services we have, and how did we decide that we were going to make the jump to Java 11? Well, there's really sort of several pieces to this. First of all, you've got to have a reason why. Why do you want to go to Java 11 at all in the first place? What is wrong with Java 8? That's a rhetorical question, Kirk. I don't need to tell me what's wrong with Java 8. Then, of course, we need to talk about things like build tools and library versions, and actually that's where a lot of the pain, to be completely honest, actually hides. It's not necessarily in the JDK itself. It's actually much more in the ecosystem that goes along with it. And then, of course, a company the size of New Relic, we have our own internal infrastructure and our own internal ecosystem, which also needed to be migrated to support Java 11. And then, of course, there's also something lurking, hiding in the back here, which is, of course, OpenJDK versus Oracle JDK. And I'll have some things to say about that as well. So why are we going to 11? Well, everyone knows why we go to 11. Why do we go to 11? We go to 11 for var, of course. Everyone loves var. That's the primary reason for migrating to 11, isn't it? I'm joking. Of course, var is just, it's a kind of nice to have, but it's not a good reason to migrate your entire enterprise onto Java 11, right? No, that would be modules, of course. Everybody wants to start rewriting their perfectly working applications and start using modules, right? Has anyone written a module? One person. Has anyone? Keep your hand up if you've written a module and deployed it to production. Yeah, apart from Martin. No, so it's not modules either. But in all seriousness, of course, it's really those removal of those EE APIs. So now you have to modify the class path of every single application. That's really why you want to go to 11, of course. No, I'll stop trolling now. So why did we do it at New Relic? Well, to be perfectly honest, the two main reasons that we had were, first of all, decent version of G1. Hands up if you know that the version of Java of G1 in Java 8 is actually a different algorithm to the version in Java 11. Hands up if you knew that. Yeah, this is one of the dirty secrets that lots of people don't talk about, and it seems that many people don't know about. It's totally different. And in fact, the version 11 is much more performant. If you're running your Java 8 applications today with G1, is that anyone? Java 8 and G1? Few people. Okay, you will almost certainly get the much better performance by moving to 11. So for no other reason, if a G1 application running on 8, going to 11, typically gets better. Kirk's shaking his head because we know that there are corner cases, but in practice, having done these migrations quite a lot, we actually have seen better performance by going to 11. The other thing to talk about is, which is also relevant to garbage collection, is compact strings. So I think, do most people know about compact strings? Basically, until Java 9, every string in in every JVM that had ever existed was stored in a really wasteful fashion, because it was stored with chars as 2 bytes, and the first byte was pretty much always 0. And that's a terrible waste of memory in all of your Java applications. So for Java 9 onwards, we have what we call compact strings, which is not the same thing, by the way, as compressed strings. In previous versions of Java, there was also a feature called compressed strings, and people quite often muddle them up with the modern compact strings. The modern compact strings basically store everything internally as bytes. So if you're using ASCII or Latin 1 characters, you don't have to store the 0 bytes, basically. And this means that your heap sizes can substantially reduce. I've seen most applications that go to 11, which are heavily string dependent, which is a lot of our applications at New Relic. 30, 40% reductions in the required amount of heap memory. And that leads us seamlessly on to the next topic, which is container friendliness. If you don't need as much memory, you can potentially put more things on the same hardware. So your actual AWS spend or your data center spend can be substantially reduced because you have better memory utilization and you don't need as much hardware in order to run things. And this is going to be an interesting question. Hands up if you are running your plant and your production systems in containers today. And hands up if you're not, because I had a sort of little bet with myself before going on stage, and I figured that we would be pretty much right on the tipping point between containers and not, and that's actually reflected in the numbers. It's quite interesting. At New Relic, we are very much a container-based shop, but in some cases we have a philosophy of what we call containerization simply for packaging. So in some cases, we're not trying to do multi-tenanting on top of the same underlying hardware. We actually have applications that run on dedicated bare metal, but simply for ease of deployment, we actually containerize even those things. So it's kind of a rich field. Okay, what else do we have? The other reasons for going to 11 were that we do have the occasional services which do cryptographic things. So for things like encryption at rest, which is something that we have to do for some cases, we require services which are capable of doing some pretty heavyweight encryption. The version of the JIT compiler, which is present in Java 11, is much, much better at cryptographic operations, and in fact has dedicated what are called VM intrinsics to handle common cryptographic operations. So if you're doing a lot of cryptography or you have Java applications that actually terminate SSL, again, you will see a substantial performance improvement if that dominates in your profiles from moving to 11. So yeah, so cryptography, just general future-proofing and having the ability to kind of not worry about the applications longer term. And of course, it's one louder. It goes all the way up to 11. So the long-term support release. I think for folks who were in Piotr's talk, I think he went into this in some detail. Basically, there are now two sorts of versions of Java. There's Java 8 and Java 11, which are what we call long-term support releases, and then you have the intermediate releases like 9 and 10 and 12 and so on, which are all feature releases. So when I started the project, we were expecting that our teams would use Java 8 for sustaining and not really bother to upgrade. But so for business as usual applications, we anticipated that people would not really want to move off of 8. And 11 would be for new apps and specific upgrades. Actually, I was pleasantly surprised because the actual reality was that a surprising number of teams wanted to move their apps to 11, even without a particularly compelling reason to do so. So our numbers of 11 apps actually took me by surprise when we actually got it into the main developer population. So what else are we going to want? Well, there's also the sort of cloud native part or aspect of this. It's friendly to containers. It has a much smaller footprint. You can write modular applications in it, and it has fast startup options, including even AOT compilation. I'm not going to say too much about AOT, but basically ahead of time compilation, or AOT, is what the C++ or the Go folks just call compilation. It means literally that before the process is started up, it's gone through some process where it's fed through a compiler and actual machine code has been generated from it. You can do it in Java applications. It's a myth to say that you can't AOT compile Java, or that it's too difficult, or that the people that write the platform are too stupid to produce an AOT compiler. I've actually heard people claim that. It's not true. We don't do it because it leaves performance on the table in most cases. And so you might ask the question, why would we want to do it here? Well, in the cloud world, when you start to have things like AWS Lambda and serverless and things like that, what you care about is lots of tiny little processes which start up very quickly and are not very large or bloated or full of capability. Startup time matters in those instances, and you don't want to wait for your full Java application to warm up. So native compilation is a good use case for those sort of small, simple, cloudy deployments. And the good news is that with Java 11, basically the gap between, say, Java and, I don't know, Python or Go is substantially reduced. There was not really a lot of gap left between Java and some of those other languages. So, okay, so why not Java 9 or 10 or 12 or 13 or where are we now? I think we're about to have a feature freeze for Java 14, which just shows how quickly time passes. Well, these releases only live for 6 months. So if you want to stay on a free Oracle release binary, you have to upgrade your Java version every 6 months. And for things which aren't LTS, there is no other support available. I think I'm right in saying that you can't even pay Oracle to support you on, for example, Java 10. You are just forced to upgrade. And here's the kicker. The community isn't using those versions. They're just not. I had hoped to have some data from New Relic available to show you to the extent to which they're not using them. But unfortunately, I couldn't quite get legal sign-off to show you. So I'm afraid you'll have to take my word for it. Anything other than the long-term support releases are a rounding error. They are almost below the level of the background noise in our statistics at New Relic. Enterprises are much, much more comfortable, or at least they seem to be in our data set. Enterprises seem to be much, much more comfortable with the 3-year cycle. And I think that's probably reflected in our experience, right? How many people, hands up if you went to your boss and said, hey boss, let's upgrade Java version every 6 months. We're not going to do any brilliant new features or anything for the customer or anything to help the business out. We'll just put it through a pointless upgrade cycle every 6 months. And very, very few people are interested in that. And less so in enterprises. In startups, it's fine, right? Because there's only 2 of you. And if there's only 2 of you, sure, you can upgrade the 3 AWS instances you have that you run your startup off, and that's not a large amount of sustaining work. In an enterprise, it's a bit of a different story. Okay, and so basically we're now in this world where I think more and more enterprises are starting to move to Java 11, but it's taken a long time. I mean, 11 has been out for a year now. And in the statistics, in the numbers, I can say that in people that keep their Java 8 up to date, about 20 to 25% of them are adopting Java 11. So we're seeing some good adoption amongst people who are in the early adopter population, if you like, but not outside of that. Okay, so that's the sort of basics of the market dynamics and why we as a company decided to move to 11. But let's talk about things like the build environment. Hands up if you're a Maven user. Gradle? Ant? One person for Ant.
Go Gradle.
Go Gradle. Okay. Yeah, very good. So for Maven, the latest version, is Robert here? I said I'd give him a shout if he was here. For 3.62, it's the latest and greatest. It works well. There are some plugins which you're going to need to upgrade. Gradle, you must upgrade to at least version 5. Gradle 4 and below do not work on Java 11, as I discovered about 2 or 3 days into my upgrade project. So the first thing we had to do was to upgrade Gradle and get everybody into version 5 of that. Version 5 is almost end of life now. So if you're starting from scratch, it may actually be better to go straight up to Gradle 6. There are substantial breakages between Gradle 4 and Gradle 6. There's a few minor ones between 4 and 5, but they're workaroundable. But a load of stuff breaks between 4 and 6. So don't underestimate how long it's likely to take you to move your Gradle version as well as your Java version. And this is what I mean. The devil ends up being in the detail. It ends up not just being the SDK you have to care about. It ends up being all the other things around it. So the build tools are simply one of the most visible examples of this that we encountered pretty quickly. Oh, and sorry, solitary person who supports Ant. Ant does not support Java 11. It's time to migrate to another tool. Thank you, Ant. You've served us well for many years, but now it's time to be taken out behind the woodshed. Oh, poor Ant. So what else? Okay, Maven plugins. Now there is the Maven versions display plugin updates. Does anyone use this? This is a good thing to do to actually see what versions of your plugins are available. And basically, I would just upgrade all of them. Just upgrade all of them to the latest version and see if that works. If it doesn't work, well, you'll have to debug your own installation. But we found that we're mostly a Gradle shop, but for the few things we have that are built using Maven, upgrading to just the latest plugin version of all the plugins seem to work for us. The 3 most common and most important, I would say, are the compiler plugin, Surefire, and failsafe. Those are obviously the compilation of the testing plugins, which is most of what you care about. So it's kind of unsurprising that those would be the most important ones. You may also need to add a configuration release stanza to your POM in order to let the compiler plugin work as that. And you may also need to set reflective access as permit. This one is kind of just a bit of sort of code wizardry. I don't really know why you would need to do that, because it's set to warn by default. But I suspect that there is some internal part of the Maven ecosystem which has something like fail on warn or something like that set. If Robert was here, he'd probably be able to tell me. But in a couple of cases, I found that sacrificing to the Maven gods by setting reflective access permit actually made it pass when it wouldn't by default. What else can we say about this? Well, if you need to deploy on both Java 8 and Java 11, there's a lot more complexity that you'll also have to get to grips with. You'll have to deal with things like multi-version jars. You'll have to deal with a two-step Maven process where you compile most of it under Java 8 and some parts of it under Java 11, and it gets a lot more complicated. Hopefully you won't have to do that. It's something that we sort of did a bit of at New Relic, but ultimately decided that for our reusable components, we would continue just to build them with 8 for now. So we haven't actually gone down the path of multi-versioning yet. Probably also worth pointing out the modules trap as well. Maven is not a module system, but it does have versioning. Java modules don't have versions. And until we get those, we're kind of stuck. So you end up with in a situation where the SDK knows about modules, Maven knows about versions, but the two things kind of don't marry up all that well. It's a bit of a seam in the build system at the moment. Hopefully at some point that will get resolved and the story will get better. But right now it is a bit of a mess. The modules sort of guidelines that I have are one Java platform module per POM. I haven't had a lot of success with either having multiple modules in a single POM or splitting up one Java module over multiple POMs. This rule is probably overly simplistic. What can I tell you? It works. I would also at this time probably not modularize unless you have to, especially not legacy applications. As we stand right now, everything that we have at New Relic is still running in the unnamed or an automatic module. We haven't gone down the named module route yet, and I don't anticipate that until the vast majority of our code is running on an 11 container. That means that sort of one of the main benefits we're probably currently not exploiting. I would hope that at some point in the coming months we'll be able to switch to the point where new applications are being written as modular first. And I think that really is the way that modules will ultimately enter the Java ecosystem outside of the JDK. I mean, the huge stumbling block is, of course, still the modules, and there's no getting away from it. This is really pretty ugly. Lack of module versioning is really pretty bad. Okay, so that's the build tooling ecosystem. The Gradle, apart from the bump from 4 to 5, was pretty painless for us. I have, however, kicked the can down the road. I didn't attempt to bring us all the way up to Gradle 6, and when I tried, the number of things that broke in our custom infrastructure made me want to put that off until another day. So I know that I have problems coming there. You may wish to take that pain up front if you're currently running on Gradle 4. Other library versions will also need upgrades. The ones that we struggle with the most, not because we use it directly, I mean, we use it in our Java Agent product, but so many things rely upon the ASM module. And the ASM module is very, very highly Java version specific. If you use an older version of ASM, it will not cope well with modern bytecode. So the ASM version also needs to be upgraded in lockstep, even if you think you don't use it. The libraries which you depend upon, a surprising number of them will have ASM as a transitive dependency somewhere. So the ASM version number will in many cases, even need to be explicitly overridden. The same is also true of cglib and ByteBuddy as well. Anything which is going to manipulate the class file format must be aware of the changes in the format between 8 and 11, because they are quite substantial. We also encountered a few libraries which still aren't Java 11 compatible. The big one here is Apache Cassandra. Who's using Cassandra? Yeah, so your Cassandra nodes at this time, they are not fully supported in Java 11. Cassandra 4 does fix this, but it's still in beta. And to be perfectly honest, I'm not at all sure that I want to be running beta Cassandra in my production environment anytime soon. The only thing that I think you can do is to really wait and see how Cassandra 4 matures before migrating to it. The Cassandra client libraries sort of work. I haven't encountered anything which has broken directly with them yet, but I'm highly dubious of it. So I haven't actually recommended that any teams which touch Cassandra directly migrate yet. The other strange one is Apache Thrift. Does anyone use Thrift? Nobody. Okay. That's surprising. I would have expected at least a few people to be Thrift users. Anyway, Thrift isn't Java 11 compatible either, or rather it is, but you can't use the compiler. So what you end up having to do is you need to have a code generation step which runs on Java 8, and then the code will actually compile and run fine on Java 11. Not quite sure why that is and what they're doing in the compiler which causes problems. Okay, and then of course be careful with your transitive dependencies. Even if you don't use one of these libraries directly, you will potentially, I think in any large enough software project, sooner or later you will encounter a transitive dependency which does rely upon one of these. Okay, that's kind of setting the scene. At New Relic we have two big sort of pieces of in-house infrastructure that we need to think about, one of which is Gradle, which we have I've got a typo on the slide. I said it ships with the bistro rather than distro. Yeah, we totally don't actually ship an entire restaurant along with our Gradle distribution. I'm sorry about that. So we have many in-house plugins. And they have, sort of the standard sort of things you might expect. We have got an application plugin which does service auto wiring. We have a Dagger plugin because we like Dagger rather than any other dependency injection system. We like Docker. We have static analysis, build info, and coverage tools. All the kind of things that we build into our Gradle distribution, so that people don't have to import these directly. All they do is pick up our Gradle distribution, and they get access to all of these plugins straight away. Alongside that, we also have what we call Grand Central, which is basically our in-house continuous delivery system. We ship thousands of releases a day, and we have an immutable build system. So basically, once a release has been prepared and deployed, it can be redeployed, but you cannot modify it after it's been created. So this, I think, is relatively mature. The attitude of the team that build it is sometimes called the just ship widgets philosophy. Has anyone heard that term before? No? It kind of means that the infrastructure layer should be agnostic or not care about what it is that it's actually shipping. So sure, these Docker containers contain Java, but the build system doesn't really care about that. It's just widgets. It's just a container full of stuff. And the build system doesn't know or care what's inside it. Related to that, we also have our container fabric, which is our container orchestration system. Yeah, we built this on Mesos because we built it a long time ago, before Kubernetes was really a thing. And you know what? We bet, we gambled, we lost. Oh well. A new version of that will be coming out next year, which will contain Kubernetes support as well. And let me tell you, using Mesos is like pulling teeth. The container fabric and the shipping of containers. Every time I have to touch anything Mesos related, I hate it. So don't do that. Don't do what we did there. Okay, so Docker. We need to talk about Docker images as well. This is another thing which people probably aren't aware of. You remember that when you downloaded Java from the Oracle website, there was a big legal thing that you clicked through and didn't read. Remember that? Did that pass people's consciousness? Yeah, there were two things in there which you agreed to and you never read, which you really are not allowed to do with an Oracle JDK, right? First of all, you can't redistribute it. Technically speaking, if you copy that file and that installer onto a USB key and give it to your friend, you have violated the terms of the Oracle license. Right? You're not allowed to do it. Everyone always does, but more to the point, this also includes in things like Docker images. If you take an installed Oracle's Java, onto a machine, copy the files and build a Docker image out of it, you have technically also violated the license. If you're using Oracle JDK, you must get the official Docker image from the official Oracle source. No ifs, no buts, otherwise you are technically in violation of the license. The other thing, which many people used to do in the past, I think it's less common now because there are less bits that you can realistically modify, is you may not modify the binaries. So you can't apply a binary patch against an Oracle JDK without permission. That includes things like time zone databases, by the way, which are now, I think, are no longer part of the main binary distribution, but it certainly always used to be the case that if you even updated that, you were technically in violation. So what are we going to do? Well, you can probably guess what the punchline is. Oracle Java 8 and 11 are now out of free support from Oracle. So what are we going to do? We're going to go to OpenJDK. And adopt is probably the easiest and lowest friction distribution to adopt. And they publish Docker images which you could download and use freely without restriction. If you don't want to use Docker, then they also have binaries which you can put inside containers or deploy in bare metal, whatever you like. On this subject, hopefully everybody knows this. Java 8 is not particularly well suited to containers. Okay? Prior to 8 update 131, it doesn't respect any settings, things like C groups for the container at all. So if you're running on 8.102, for example, it just can't see the container. It will see the physical number of CPUs on the box. Now that can be a real problem because things like the number of threads that such a VM will spin up for garbage collection will match the number of cores on the box. And if you're in a 4 CPU container and you have 64 GC threads, who thinks that's going to be a happy time when you do a parallel GC? Yeah, it's not. Later than 131, you get a few more nice things. 191 actually has most of the 11 fixes backported to it now. So a modern OpenJDK 8 actually is pretty much on parallel with an 11 now. Things to be careful of and to watch out for: GC threads we've talked about. The number of threads in automatic VM-sized thread pools, because you know that in Java 8 you have some internal thread pools which are used for certain operations. Those are automatically sized as well, and you may need to add additional flags to size those correctly. For Java 11, much better resource limitation support, CPU limits, memory limits as well. You should rarely see an out-of-memory error due to container restrictions compared to Java 8. To be honest, when moving from 8 to 11, we took the opportunity to examine each set of JVM flags when migrating each application over. A lot of times, there's some kind of flag archaeology which goes on, and you look at the flags and you think, why on earth did you set this flag? And they said, oh, well, I read it was a good idea on Stack Overflow. How many times have I seen that? Take this opportunity, if you're upgrading the VM version, to actually go back. For all of your Java programs in production, you should be able to tell immediately and give a clear answer as to why each command line flag is set. If you don't know, then that's bad. You are carrying unknown technical debt for no real good reason. So if you're upgrading from 8 to 11, the drains are kind of up at this point. You are going to need to retest each application in turn as it moves over, so take the opportunity to revisit the flags and make sure you know what they all do. Okay, so let's just talk a little bit about the support model and the mainline version of Java. So before we talked about these, we used to call them major releases, but actually Oracle prefers the term feature releases. They're every 6 months, they're only supported for 6 months, but crucially, they do still count as major versions in terms of feature deprecation. Oracle always had this idea that features would be maintained for one major version when marked as deprecated, and then could be removed after that. They've kept that into the feature releases. So if you move from 8 to 11, things can just be gone from underneath you, because things could have been deprecated in 9 and removed in 10, and then they're just not there from 11. So in the attempt to make it easier to upgrade from smaller releases, it's actually made it potentially more problematic when moving straight from long-term support release to long-term support release. These come out every 3 years, and technically, you see, this is merely an Oracle thing. You know, there's nothing in the OpenJDK which marks 8 and 11 as the long-term support releases. But in practice, that's where the market is. Nobody is using anything other than an LTS release. Will that change? I don't know. You know, this time next year, we're probably going to get 15, and in 15, we'll probably have records and algebraic data types and some other nice things. Will people migrate to that just because they want to get access to those features early, rather than waiting another year for 17? I don't know. The marketplace will decide. But if I was a gambling man, I would say it's going to be 8, 11, and 17 as the versions that people actually use. So what this means, of course, is that Oracle's role in Java is diminishing. And OpenJDK is where everybody is going. So the non-Oracle vendors are becoming important again. Free support is still available, you know, for a long period of time, not just for 6 months, but it just won't come from Oracle anymore. So at New Relic, we looked around and we chose Adopt OpenJDK, and we're sponsoring the project. We have our own internal pre-made Docker instances that we build, which is especially designed to work with the New Relic infrastructure. At this point, I took the opportunity to actually work with the container team and so move them away from this idea of just shipping widgets, and to actually say to them, hey, you know, the majority of the stuff that we have running in our container plant is Java. It's the mainstream case. So how about you give me just a couple of tiny little things just to make the job of developers a lot easier, so that the container plant is aware that that container on that host there is actually running a Java application. So having those tiny tweaks into the infrastructure has really started to pay off and make a big difference. And going along with this, we also have the idea that we would ask our teams not to use just random mystery meat OpenJDK images that they found somewhere on the internet. You know, please don't just go out onto the internet, download random binaries, and run them on our infrastructure. And if you have special requirements, or for some reason you can't work with the standard image, then, you know, the idea is they would come and talk to us, and we would help them. So what does it mean for our teams? Oracle JDK is a significant risk. If you're still running Oracle JDK and you don't have a support license, you have a big fat target painted on you. You are not going to get any more security fixes without paying for it, and you need to really come to OpenJDK. So internally, we set the rule that it was mandatory to migrate to adopt OpenJDK, even for Java 8 apps which weren't being upgraded, and to upgrade to Gradle 5. So this basically was the kind of the path of least resistance to get our teams up and running, at least on OpenJDK, and within an infrastructure which can then be upgraded to Java 11. So the next step, of course, is to get people to upgrade from adopt OpenJDK 8 to adopt OpenJDK 11, and to start by writing new services. So when a team just wants to build something new in our infrastructure, that unless they have a very good reason, it should be Java 11 by default. And you know, this is kind of the carrot and stick approach. You know, the carrot is they get special help to come to 11 early, and the stick is don't be the trailing edge, because then the security people come along and beat you with sticks. So where are we now? Well, 75% plus of all of our stuff has migrated to Gradle 5, and I just checked the numbers before this talk, and we have just about crossed over the 70% migration to adopt OpenJDK. So I'm deprecating Oracle JDK for removal, and the images will be going away, and help for carrot and stick. Some other things that we also touched on. The regressions that we found was a big part of what slowed down the migration. Lots of people were very unhappy about moving away, not just from 8 to 11, but also regressions between Oracle JDK and OpenJDK. I had 7 separate reports of performance regressions. 5 of them I tracked down, and they were proved pretty quickly to be phantom. 2 of them were trickier. And in both cases, it took quite a bit of detective work to uncover the fact that actually something else had been modified at the same time as we changed JDK. The moral of this story is there is absolutely no reason, certainly from moving from Oracle JDK to OpenJDK, that you would see any performance regression whatsoever on any of your server-side binaries. If you see an effect like that, it's time to question your assumptions and to go back and look at it really, really closely. I have never seen one which has actually been borne out. Another thing to be careful of is the metrics of how you measure performance. In particular, lots of people came to me and said, well, when we upgraded from 8 to 11, we saw GC CPU utilization go up. Okay, well, maybe. But is that necessarily a bad thing? You know, if your box is only running at 20% capacity and you see an extra 0.5% being picked up for GC, you know, maybe that's not a thing to worry about. You know, Java 8 defaults to parallel. 11 defaults to G1. G1 is a concurrent garbage collector. It's going to use more CPU than the equivalent parallel case. It just will, because it's doing stuff while your application threads are actually running. So of course you're going to see higher CPU utilization. Again, navigating that is not a technical challenge. It's a human's challenge. It's not something which you can fix directly with tooling. You just have to go and talk to people. So what we're really doing is we're building this thing. That's really what's underlying the move to Java 11, is to enable us to go faster, to build outwards from metrics to what we call observability. So effectively a platform built around things that you care about, with programmability. So we want to do everything using our query language, everything with GraphQL. All of our services are now being enabled to speak GraphQL. Has anyone programmed in GraphQL yet? A few people, yes. If another thing to, alongside Apache Kafka, the thing which I think is the most interesting in our architecture is the GraphQL piece. Now, it has historically not been that easy to program in Java and use and deploy GraphQL APIs. Fortunately, we're about to open source all the tools and the libraries that we've written in order to allow you to do so. So there's some cool stuff coming out. New Relic One's an open platform, so it means you can basically build your own visualizations and your own things on top of it in pure React. This now means that we're starting to move towards a much more open architecture. The pipeline I showed you before is very kind of closed in. It's got proprietary code basically all the way through. We use open source components, but a lot of it is very closed and proprietary. The architecture that we're enabling, and the reason for doing all of this, is about opening all that up. So if you want to send us data in open tracing form or Zipkin, or however you want to send it, we can accept that data in those forms now. There's discussions about open sourcing the agents, and you can build desktops. So this is the architecture that we're actually building now. Open source agent at the top, core data pipeline, Kafka, and then new APIs which enable you to speak GraphQL. So you can effectively just treat New Relic as I guess, kind of a storage engine. So we'll just hold your data for you, and you can access it, send it to us in whatever format you want, including open source, so there's no vendor lock-in, and you can access it either programmatically or through the dashboards. So this gives you a whole bunch of different ways to come and talk to us, and we're migrating and moving to Java 11 for reliability, performance, and basically to accelerate the delivery of the new architecture. So that's kind of our master plan. We want to be in a place where the vision of having the open architecture is delivered much sooner. And like most tech companies, we're hiring. So I'm based in Barcelona, hence the T-shirt, and we have about 120 devs. It's a really nice place to work, and I've got lots and lots of jobs going. Thank you very much. I have 2 minutes for questions if anyone has them.
You were looking for me?
Yes, Robert. Because there was a Maven shout out early on.
Perfect. Well done.
For people that don't know, before the conference, Robert's made a bet. What was it? 80% of talks would mention Maven in one way or another. So I'm just doing my bit to keep the numbers up. Questions? Anyone else have a question? No? Okay. So I think the one thing I didn't put in my slides is when do I think I'll be done? It's a good question. I think we'll probably be fully migrated to the point where new things are being written on 11 probably by the end of the year, and I think we'll probably hit the tipping point of more 11 than 8, probably about halfway through next year. These things take a long time. Okay. Questions? Heckles? Kirk? No? Okay.
Before 17 comes out.
Oh yes, definitely before 17 comes out. Okay, thank you.